after looking at all the restrictions that we've done so far, we've never seen a restriction with a square under it. And here's the biggest mistake students do. Well, they figure, well, that one's a squared and that one's a squared. All you got to do is square root it. This should be x minus 4, right? Wrong. That's the biggest mistake students do all the time. Because what you have to realize here is this. That's x squared minus 16, which is a difference of squares. That actually works out to be x minus 4 and x plus 4 when you factor it, leaving you two values, x equaling to 4 and x equaling to minus 4, or like we like to say, plus or minus 4 is our answer. But here's something that a lot of students don't realize. When you're dealing with a radical, that's that square root thing, and you're looking for the restriction, this becomes a little bit more challenging. And I'm going to show you something different other than just going out and factoring it as a difference of squares. I'm just going to write it over here and say, okay, as a restriction, you know and I know that has to be greater than equal to 0, okay? Because everything under that square root would not be square rootable if it was less than 0. So there's a restriction. It has to be bigger than or equal to 0. So let's just solve this like it would be just a normal algebra equation. So you add your 16 to both sides. Add 16 to both sides, giving you x squared, which is 16. Square root it. And of course, everybody knows that when you square root something, you have to use that plus minus principle, right? Okay, the square root principle. So that's where the plus or minus 4 comes in. So far, we're no different than this one. But here's the thing. When you square root with an inequality, okay, that becomes kind of interesting because you have two answers. If it's just a positive one, yeah, that inequality stays the same. But when you make it the negative one, same rule applies as dividing by a negative or multiplying by a negative. This, you have to flip the inequality, okay? Because it becomes a negative. Doing it this way doesn't really show you that, but now that you've seen it, you can actually write this in like this. That's kind of cool. So what does this mean? It means basically any value of x that is bigger than 4, right, will make this thing work. Now, let's go back to this. What was that thing? Remember, we wanted the square root of x squared minus 16. So if you look, try a value that's bigger than 4. Try 5. Okay, look, 5 squared, right, minus 16, is that going to be square rootable? That's the question that you have to ask yourself. Okay, so 5 squared minus 16 is 25 minus 16, which gives you, of course, 9, which is square rootable. That works. Now, look what happens when we do the same thing, but now let's look at negative numbers. A number smaller than negative 4 would be negative 5. And look how this becomes exactly the same kind of question all over again, because you put in negative 5 here and you square it, minus 16. That gives you 25 minus 16, which again is 9, which is square rootable. That works. But look what happens if I use just the opposite on this one. Right? If I didn't flip this inequality, it would say x, any value x greater than or equal to negative 4. Well, let's pick a value greater than negative 4. Let's try negative 3. Watch what happens. If we put that into this x squared minus 16 here, watch what happens. This becomes 3 squared minus 16. That's 9 minus 16. Uh-oh, we got a problem here. That's negative 7, which is not square rootable. That's why we have to flip that inequality. See that? So it becomes incredibly important when you square root that you have one originally with the plus going this way, one flipped with the negative going this way. You will see that again an awful lot in Math 30-1. That comes up and it sneaks up and it bites you. But guess what? You saw it here first.